just having a word about the back market.
Thank you. Welcome everyone to Back Market Offices. Despite what you saw on the front door, we are not a plumbing company. And so I will introduce quickly in a few minutes the company and tell you more about what we are doing. We are the first of our kind, and let me tell you the story of Back Market very briefly. The story goes back to 2014, and the company has been started by three rebels with a cause: Vianney, the creative, Quentin, the techie, and Thibaut on the business side, with a mission which is reducing the impact of digital devices on the planet, on the world. Our North Star is there is really no more reason to buy new. What does it mean? It means that we are pushing for reconditioned devices or refurbished devices, which means electronic or electric devices that has been that had the life before and that has been checked, eventually fixed and put back on the market. So our purpose is to build a more circular economy and move from the linear economy, which is we always buy new stuff requiring extracting raw materials, etc., and having a really huge bad impact on the planet. And also we try to do as much as we can to extend the device's lifetime, which is the whole idea of the refurbishment. We are a marketplace, so we are between the merchants we onboarded on our website, to which we provide services and a lot of added value, and customers. So we act as a tier of confidence between the two. A word on sustainability at Back Market and the impact we had. So just in 2021, thanks to the sales of smartphones only, and we don't sell only smartphones on Back Market, we sell many other electric and electronic devices. We helped avoiding this big number of e-waste and this equivalent of CO2 emissions. Just a few words on our culture, which is a very sabotage culture. You may have already noticed if you are attending physically. Our 5 principles are the following: think deep, decide fast. This is Sparta: minimum resources, maximum impact. One loving and free-spirited tribe, and it's not been enough. This means that we are a startup trying to have a great impact, try to achieve more with less, collectively, and always think about our carbon impact on everything we are doing. Of course, how could I conclude this introduction without this slide? We are recruiting. You can see the job offers on the jobs.backmarket.com website. There are plenty. Join the revolution. It's now. And that's all for me. And I'm giving the floor to Nicolas from Cilium. Thank you.
Hi, everyone. Thanks for having me here. It's really nice to see all of you gathered to see the talks. I am Nicolas. I am a software engineer working at Isovalent. And today we'll talk about Cilium. Cilium is an open source eBPF powered cloud native networking security and observability software. So that's a lot of buzzwords, right? It's also a CNCF incubating project, which is nice because this is a CNCF event. I personally contribute to Cilium, mostly on CI/CD. So I may not be able to answer all your questions if they are deeply technical about specific features, but I will try. The goal is for me to talk about 30 minutes, and then we will leave about 10 minutes for any questions you may have. If that sounds good to you, and I hope it does, then we can start. So first, what is eBPF? eBPF is the technology on which Cilium is built. And in short, eBPF is a technology that makes the kernel programmable. Some say that eBPF is basically giving superpowers to the Linux kernel. And indeed, there is a lot you can do with eBPF. In practice, eBPF allows you to attach business logic to pretty much anything running in the kernel, which opens up areas like security, tracing, profiling, networking, or observability in a way that is both safe and efficient, right in the kernel. So eBPF is really hot right now. The eBPF Foundation, with members such as Isovalent, Facebook, and many others listed at the bottom, is overseeing eBPF maintenance and development. And in fact, it's so cool that even Microsoft is getting in on the action and is currently making a Windows port of eBPF. So hopefully, at some point, eBPF will be able to run also on Windows in full capacity.
So what does it do exactly? So
I will talk about that in the next slide. So there was a question about what does it do exactly. So for a very quick summary that I like a lot, before eBPF, when an application developer wanted to have some kind of specific feature to observe an application, for example, you could go to the Linux kernel developers and ask them to implement that feature, and they will say to you, give me a year to convince the community that it is a good thing for everyone. And then 1 year later, they will say, yeah, I'm done. Now the kernel supports this. And then you'd have to go to the Linux distros person. And that person, 5 years later, will come back to you and say, good news, now our Ubuntu distribution or something, now ships the kernel with your feature. And at this point, obviously, your requirements have changed, so it's useless, right? And the thing that is really nice with eBPF superpowers is that now when an application developer wants a new feature, the eBPF developer, here with a cool Cilium shirt, is going to tell you, well, the kernel can do this right now, but I can solve it with eBPF. And in a couple of days, you can release something that has the feature and makes your kernel programmable and usable for your own project. And even better, you don't even have to reboot your machine, which is nice. So this is the power of eBPF. eBPF is a way to add programmability inside the Linux kernel without making the kernel itself evolve and without using the older methods, for example, kernel modules, which are not as reliable and safe as eBPF. So basically, what technically happens is in user space, you have your application that will load an eBPF program inside the kernel. And this eBPF program is going to be able to listen on specific kernel events and then execute custom logic represented by the eBPF program when these events happen. So what is very nice is, since you are loading code inside the kernel, obviously you don't want the kernel to crash because that is bad, very bad, terribly bad. So there is a verifier that is going to guarantee that your code cannot crash the kernel. Basically, there is a static analysis that is run, and this verifies that under specific constraints, your program is unable to crash, and thus unable to crash the kernel itself. So that means you can do everything you want to do with eBPF. It's a bit more complicated to do some things in eBPF than in regular programs, but it is safe. And once you have mastered it and you know how to use it efficiently, you can make programs inside the kernel with everything that the kernel can see itself. And this is key, because when you are inside the kernel, you have the context on everything. For example, if you have eBPF powers, you could attach to the read syscall on the top left of this chart, which means that anytime a process tries to read the file descriptor for any reason, that triggers an event. And in eBPF, you can execute custom logic at this point. So for example, if you wanted to trace and observe all programs that are reading files inside your system, that is doable. You can just log that somewhere. But even better, you can actively do things. And for example, if you wanted to block a specific program from reading a specific file, you could do that. So if you wanted to block totally not suspicious, whatever executable to read /etc shadow, that is doable as well, because you have all the context you need and you are directly inside the kernel reacting to all events happening in real time. And since all the kernels are event-driven, anything that comes in from physical or virtual devices, like for example, network cards or storage devices, and anything that happens with any process making any system call, all of that is available to eBPF. So I guess now you can see the power of eBPF. Having access to so much context is the key, and why eBPF is so powerful, and why Cilium, which is built on top of eBPF, is able to do all these things that we are going to talk about in the next slides. All right. So the goal of Cilium is basically to make the kernel microservices aware with the help of eBPF. It leverages eBPF superpowers, and when used in conjunction with, for example, Kubernetes, it can be used to control and observe all traffic in a cluster. It could be used to determine specifically which DNS queries failed in the last 10 minutes, and with as much context as possible to help you troubleshoot these failures. So here's a quick chart of Cilium inside a Kubernetes cluster. Basically, Cilium, which is at the center, is responsible for implementing everything when it comes to network policies, services and load balancing, bandwidth management, flow and policy logging, and then ops and security metrics, as well as in-cluster networking, notably pod-to-pod connectivity, node-to-node connectivity, and cluster to world and world to cluster connectivity as well. And all of this relies on eBPF superpowers in the kernel to do the job. So we are going to dive into that in the next slides. But first, a little bit about Cilium users. You can see a lot of logos in here. We have highlighted a bunch of the most thorough use cases that we have, notably from Google, Datadog, and Adobe, GitLab, and Bell. I think Datadog is French, so that's cool. And we also have Radio France at the bottom. So they are also users of Cilium. So you see that plenty of people are using it, especially big companies with big clouds and big Kubernetes clusters. And typically what we hear from our users is that they are very satisfied with Cilium and how efficient and scalable it is, for the reason we are going to explore in the next slides. So this is just to show off, basically. The nice thing about Cilium is that thanks to the community, because of the open source side of Cilium, it is available on basically any cloud and with any Kubernetes installer. So if you want to use Cilium on AWS or GCP or Azure or Alibaba Cloud and install it using Rancher or Kubespray or something else, all of that typically will be doable. We have a nice documentation that helps you get started on any kind of cluster you like with any tool you like. Then some notes about Cilium use cases before we will dive into each of these sections and highlight some specific topics that I really like. So here is I would say, exhaustive listing of everything that Cilium open source can do. And typically, you will use Cilium as a CNI plugin inside your Kubernetes cluster to do everything Kubernetes networking in a way that is both efficient and flexible, from routing to overlay and even cloud native provider integrations. Also, multi-cluster routing. I'm going to talk about that, but you can connect multiple clusters together, which is really nice. Then you could also use Cilium as a load balancer to do L3, L4 load balancing inside your cluster for your Kubernetes services as well, to replace kubeproxy in a, again, efficient and scalable way. And you could also do north-south load balancing using maglev. Then we have a new use case that is coming in the next release and is currently in beta state, the service mesh. So this use case is to basically do sidecar-less eBPF accelerated service mesh. So you take everything that you have in your current service mesh, for example, Envoy, and you do the same, but without sidecars, which greatly improves the efficiency of your cluster. We'll have more details about that later. And then, of course, we can, with eBPF, dive into security and observability concerns, because we have deep observability inside the kernel itself. We can see everything that is happening in real time and also can react in real time to everything that is happening, which enables us to do things in Kubernetes that you might think were not possible, such as DNS-aware policies, which is really nice, or encryption, transparent encryption. Without doing anything, it's just a switch in Cilium, and then boom, everything is encrypted inside your cluster. Or API-aware policies at L7. So everything from HTTP to gRPC, Kafka, Cassandra, whatever, we can have policies for that. And in terms of observability, you can observe basically all the traffic inside your cluster, pod to pod, node to node, in and out of your cluster. Everything is visible, and you can really feel like a god looking inside your cluster. So let's dive into some of the more specific highlights from these use cases, starting with Kubernetes networking. So by default in Kubernetes, the CNI plugin is responsible for allowing the pods to communicate. It handles network configuration for the pods, handles IPs and routes, and also the traffic between pods and across nodes. This can be done in various ways, for example, by encapsulating all packets in a tunnel mesh, or by integrating with the network to provide direct routing. And historically, this logic will be implemented using IP tables in the kernel, such as with kubeproxy, which is displayed right here. And typically, IP tables, it defines chains of rules. Like if you see this IP, okay, pass it on. If you see that IP, no, drop it. Or sometimes it will be a bit more involved. Like if you see this IP, modify it in this way, and then send it out over here. And it works, but it has its limits, as we'll see in the next slides. On the other hand, when Cilium does it, does it using eBPF. What happens is Cilium will run on each node as what we call the agent, and it will produce tailored eBPF programs for each pod. And this allows deep control and context to be used when implementing networking inside your cluster. When using microservices, which moves the logic into more and more components, the network usually becomes the nexus of your application. So you really want to make it efficient because it will allow your apps to scale better. And you also want to make it observable because it allows you to know what's going on when something goes wrong. And this right here is the goal of Cilium. So let's have a look at one example. These are Kubernetes services. Services are all about providing consistent IP addressing for applications to talk to each other. So for example, here, if app 1 wants to discuss with app 2, you could use the direct IP address, for example, 10.0.1.11. But if you do that, it's reliant on the existence of that specific pod right there to be available. And if the pod goes away, then you'd have to update app 1 to point to another pod, right? So obviously you don't do that. Instead, what you do is you talk to a service, in this case, a cluster IP service, and the cluster IP service is responsible for doing that for you. So app 1 only needs to know about this service IP right here. And then the networking plugin will handle the connection for you. So when app 2 is scaled up or down or moved to another host, app 1 doesn't need to be updated at all. It just connects to the service, and the CNI plugin is handling everything. This model makes it easier to deal with the ever-changing and ephemeral nature of microservices, but it relies on the networking plugin to deliver the traffic. And again, in many clusters today, this is IP tables, and IP tables is not scalable at all. So here on the left, we have eBPF-based rules, and on the right, we have IP tables-based rule. And in IP tables, what happens is you have a static list that is used, and the changes are not atomic. So even when you change only one rule inside your big list of rules, what really happens under the hood is that all of the rules in your list are reevaluated all at once. And of course, this scales very, very poorly in a Kubernetes environment because the problem gets worse and worse and worse as you scale in any dimension, whether it be pods, services, nodes, or ports, etc., etc. So in Cilium, we implement this same logic using eBPF maps, and specifically a hash table that can perform the IP translation in constant time. So that means that not only we can read instantaneously, we also can update the hash table in constant time, so instantaneously. And this is how we keep network efficient, even with microservices at scale. And is really, I would say, the reason behind the existence of Cilium. Everything came after. This is the starting point. On top of Kubernetes networking, like pod-to-pod connectivity, Cilium offers deep integration with cloud providers such as Alibaba, AWS, Azure, Google, etc. And here we have an example of Cilium used in combination with the AWS VPC CNI plugin. And in this hybrid mode, Cilium relies on AWS VPC CNI for IP address management via elastic network interfaces. And then Cilium resumes its regular operations, namely attaching eBPF programs, for example, in order to enforce network policies, perform load balancing, provide encryption, etc., etc. So this is just one example, but we have the same for all the cloud providers that we support. Likewise, Cilium can, in fact, be chained with almost all other CNIs. So if you would like to chain Cilium with any other CNI, you'd have the other CNI that, for example, is responsible for device plumbing, IPAM, or routing, and then Cilium can still do its job on load balancing, network policies, encryption, multi-cluster, visibility, etc., etc. Another feature that our users really like, and I talked about that earlier, is the ability to run multiple clusters and connect them together. For example, for fault tolerance or disaster recovery. Cluster mesh allows for cross-cluster pod-to-pod connectivity, and even cross-provider when the clusters are deployed on different providers, which is really nice. And with this, it becomes possible to enable global services that will transparently be exposed on all the clusters. So then you don't care about where your pods actually are in your clusters. It works transparently for anywhere in all your clusters. And likewise, I don't have a slide for this, but you can actually cluster mesh together Cilium agents inside the Kubernetes cluster with Cilium agents deployed on external virtual machines. We call that external workloads, which means that if you have legacy virtual machines that you want to join inside your cluster, you don't need a load balancer anymore. You can just like join your actual virtual machine with the cluster, and boom, it's transparently available from your pods. Okay, then we go to load balancing. So typically in Kubernetes, load balancing is actually not included. You have sort of something with node port, which is the closest implementation you will have to load balancing. It works, but it's not aware of cloud native constructs like pods. So this means that you might end up with a situation like 2/3 of your capacity on one node, but the load balancer is still sending 50% of the traffic there. And typically it's not able to scale or adjust based on pod provisioning. So typically what you want to do is to have an external load balancer. And when you do that, you rely on the cloud provider to do that for you. You need the cloud integration. So instead, with Cilium, you can have load balancing at the L4 layer directly within your CNI. And you have nothing to do, no integration to be taken care of. It's pod aware, uses maglev, and it can be either run in standalone or distributed mode. So you keep that rich context and control for the services that you have of type load balancer. And this is regardless of where they are. It could be in the cloud, it could be bare metal, doesn't matter. Cilium handles it for you. Then we go to the service mesh use case. So service mesh is right now currently in beta state. It's going to be generally available in the next release 1.12, which is happening somewhere in the next few weeks. And what it does basically is to accelerate what you were already doing with service mesh inside your clusters. So typically in traditional networking mode on the left, you'd have your service mesh here with the Envoy logo that goes through all these hoops just to get to your app, because it has first to reach the node itself. Then it goes from the node via virtual interfaces to your pod. And then once it's inside your pod, it goes through first to your sidecar, which is Envoy. And then from your sidecar, it goes to your actual application pod. So you see that it's a mess, right? On the right, with eBPF acceleration, what happens is you don't have a sidecar anymore. You don't need to load sidecars inside your pods. Just have your app pod be deployed, and then Cilium is going to be handling all the service mesh networking for you. So we have just released a blog post about this, but typically, compared to traditional networking, we see a 3x increase in terms of networking speed. So that's not nothing, right? Oh, here it is. I forgot I had this slide. So you can see the benchmarks on the right, and they are found. You can go to the cilium.io website to read the blog post and see more about the methodology if you want to try and reproduce on your own environments. And then we get into the two, I would say, more regular use cases, security, and we'll do observability after that. So when it comes to security, for every pod running inside your Kubernetes cluster, Cilium is going to assign a unique identity, which makes it possible for you to do identity-based security and really deep dive inside your cluster and the security model. If you want to implement a zero trust model inside your Kubernetes cluster, typically you'd want to be able to differentiate every workload in there, and with identity given by Cilium, this is doable. Then we have API-aware authorization at the L3 level, at the L4 level, and also at the L7 level. So this means that you are capable of creating network policies that understand each of these layers. For example, I have an example here with Cassandra at the L7 level. This is a Cilium network policy. So it's a sort of superset of Kubernetes network policies. And what it does here is we have deep integration with the Cassandra protocol and are able to look into the query action of type select on the query table, my table, and then define a network policy specifically for that. And we have the same for other protocols, right? So if you want to look into HTTP or gRPC or Kafka, whatever, that is doable with our network policies. So this is really nice. And then we also have DNS-aware policies. Again, Cilium network policies allow you to do FQDN-based policies. So if you want to allow traffic only to specific FQDNs, that is possible with Cilium network policies. And again, not something you can do with default Kubernetes network policies at all. Sorry. Then we go to go back to L3. At the L3 level, we have very deep matching capabilities, which allow you to craft network policies based on everything Kubernetes. So pod labels, namespaces, service accounts, service names, cluster name, whatever. We also have deep integration with the cloud providers, of course. So if your cloud provider uses labels for instances or allows you to access VPC or subnet name and tags, that is also available inside Cilium. We saw that we can use DNS names as well, CIDRs, and of course, have access also to logical entities, which means that everything that is inside your cluster or outside your cluster or on localhost is exposed via eBPF to Cilium. So it is available for you to match when you are crafting your security model. On the observability side, I want to talk about Hubble. Hubble is our observability component inside Cilium. It allows deep observability thanks to eBPF. And by default, Hubble runs in each Cilium agent, so on each node in your cluster, but it's only exposed via gRPC and locally. So by default, it's not that useful, right? But we have three components here, Hubble UI, Hubble CLI, and Hubble metrics that allow you to access Hubble data in a user-friendly way. So in the center, the Hubble CLI allows inspecting network traffic from the command line. Hubble UI does basically the same, but from a web UI, so that's a bit more friendly. And then Hubble metrics, which you can integrate with monitoring tools such as Grafana, etc., which allows you to retrieve some data about your cluster. So here's an example of flow visibility with Hubble CLI. On the left, we have a Kubernetes cluster with a bunch of pods deployed. And then we run the Hubble CLI observe command to see the network traffic happening inside of a cluster between these pods. And you can see that we have the DNS lookup flows shown at the top, then the successful HTTPS request to that same FQDN that we just looked up, and then another blocked HTTP request that was denied by some policy we had deployed inside our cluster. So what's really nice here is that you have everything really happening in your cluster, but on top of that, if a traffic is denied for any reason, Cilium is going to try and tell you why it was denied. Here you can see policy denied, which means it was our doing. There is a policy somewhere that blocks this. but it could be something else. For example, it was dropped because there was a mismatch between IP and identity or something. And then it allows you to investigate more thoroughly what the issue is with your application. And when you are making network policies, this is really useful because then you can also verify that your network policy is actually doing what it's supposed to do. And if you messed up somehow, then it will show you. Then we go to the Hubble UI. It's, again, basically the same. You can see the network traffic happening in real time inside your cluster as from the CLI. These network flows are shown at the bottom in this table. At the bottom is actually exactly the same as the previous slide. The network flows as if you were showing them from the CLI. But on top of that, we also are building a service map, which is shown in the center. And this service map is a way for you to visualize what is happening inside your cluster. And this is really cool because then as the network traffic is happening in real time, you can see the various pods pop up and the flows going from one pod to another, or even from one pod to the outside world, or from the outside world to one of your pods. So this really helps when you are trying to make sense of some developer application that was deployed in your cluster that is acting strange for some reason, but you know nothing about this application. So you can really focus on what you want. And just like, I actually forgot to mention that, but on the Hubble CLI right there, you can of course see the network traffic, but you can also filter selectively. So we discussed earlier all the matching capabilities. You can filter by pod, you can filter by label, you can filter by protocol, you can filter by port, you can filter by whatever you want. All of that is doable from the CLI and also from the UI. So the UI, actually, if you click at the bottom, I can't show you because this is a slide, right? If you click at the bottom on each of these flows, it actually allows you to then select specific parts of the flow that you want to filter on. And so you can see overflows that look like this one you just selected. And this really helps you when you are trying to craft a Hubble query to see specific network traffic inside your cluster. All right, so this concludes our very quick tour of Cilium. I didn't present all the use cases, but only the ones that typically our users like the most. If you want to get hands-on with Cilium, I suggest that you go to cilium.io, specifically to the Get Started sub page. And on this page, you'll have pointers to everything you need. You can either dive in yourself using documentation and tutorials. We have a live tutorial on Instruct. So that's really cool because you don't have anything to set up. You can just try it out in an environment that is brought up for you. You can also join our weekly live Q&A with Thomas Graf, which is the co-creator of Cilium. Or you can join our monthly community install fest, either on Europe or America's side. If you join on Europe, I'll be there. And other than that, thank you. If you want more information, you are more than welcome to come to our Slack at slack.cilium.io. The open source community is really nice. So if you have any question regarding Cilium or hitting an issue or something, please come and ask away. Typically, you get help. And Isolan folks like me, we are also there and trying to help. You can also go to github.com/cilium/cilium if you want to see the code, contribute. You are more than welcome. We have a good first issue label if you want to start with helping on something. And then our website and Twitter account, cilium.io and @Cilium project, if you want to follow us. Thank you again for listening to me. And if you have any questions, please ask away.
So we can conclude that as Cilium, it's like a service which you provide services or process for our cloud, like load balancing, like firewall features, like netting, like that. That's right. Or
so the question is Cilium some sort of service that provides feeders for your Kubernetes cluster?
Yeah.
So yes, and then more. So Cilium can be used as the CNI plugin inside your Kubernetes cluster, in which case it will handle all the networking inside the cluster itself. And then on top of that, Cilium also offers other features, such as the ones we just mentioned, for example, to connect two clusters together, or load balancing at the L4 level without any type of external load balancers, or service mesh acceleration, etc., etc. So it's open source, so it's not a service that you buy or whatever. You can install it yourself. Then I have to also mention that since we are a company, Isovalent, we donated Cilium to the CNCF, but once a company wants to have support on their Cilium use cases or want some of the more advanced features, you can also reach out to us, in which case we provide the service to the Isovalent enterprise distribution. So it works a bit like GitLab. You have an open source version, open core, that everybody can use. And then if you want more, you can go to us and we provide you with the enterprise distribution.
Great. So
I have two questions on Zoom. So you have to maybe
yes, question from Seb. Question from Seb on the chat. He asked if he's already using Calico as a CNI. What would be the benefits of using Cilium, and how can he convince his team to move to Cilium?
Thanks. So that is actually a great question. Sorry. Calico is indeed one of the other CNI plugins you can use in Kubernetes. If you are happy with your Calico CNI plugin right now, I would say there is no reason to change. But as a Cilium contributor, I must mention that typically we have made benchmarks and we see that Cilium is more performant in our benchmarks than Calico. So maybe if you are under stress in terms of hardware or network capabilities, it would make sense to evaluate Cilium as a better option to improve your Kubernetes cluster efficiency. And for that, you can look at our benchmarks again on the Cilium.io website. And then afterwards, if you want to make the switch from Calico to Cilium, we have reports, a lot of reports from users that previously used Calico and now use Cilium, which might help you steer the discussion in your own company from people that have done the same already and why they did it. I hope that answers the question. Also, good remark from one of the persons here is it is possible to run again Cilium in chaining mode, which means that then you have Calico running, handling the networking for you, and Cilium handling all the other features that we just discussed. That is not, of course, the optimal way to do it, but that is one way to do it. Yes.
Regarding the service mesh part, what is the level of integration with service mesh solution? Is there a list of service mesh that are supported?
So the question is regarding service mesh, is there a list of service meshes that are supported by Cilium at the moment? I actually don't know the answer to that question. We have a service mesh beta repository on GitHub. I suppose the answer is there. What I can tell you right now is that at least it works with Envoy and Istio. But I couldn't tell you if there is a specific list of things we support or don't support.
Cilium should be integrated while eBPF as a plugin inside the kernel, that's right? So Cilium cannot work with another plugin, let's say, or eBPF should exist anyhow.
So to rephrase the question, is the question, can Cilium work without eBPF or, okay. So Not really. So Cilium relies on eBPF to do most of its operations at a low level. So if your kernel does not support eBPF, it is not possible to install Cilium at all. I think the older kernels that we support is kernel 4.9, which on most distributions, because it varies per distribution, on most distribution has the eBPF features, the minimal set that is required to run basic Cilium features. Then the higher feature sets of eBPF you have, the higher feature set of Cilium is available to you as well. So you always have to check, depending on your own hardware and distribution, what is available or not. But typically on most distributions nowadays, eBPF is available at a high enough level that Cilium can work for everything. It's used not to be the case a few years ago, but now there's usually not an issue with that. Does that answer your question? Okay. Yes.
Okay, some question in the chat. First one is about testing, and I don't remember. It's Hamza who asked, is it possible, or how do you unit test your scripts, your eBPF scripts, and do you have any CI stuff?
So thanks. That is a cool question. I actually am working on CI/CD at Cilium, so that helps to answer. For eBPF programs themselves in Cilium, most of the eBPF programs we write are Go-based. So what that means is that we have eBPF programs, actual eBPF, that are embedded in strings in Go, and this gets compiled by our toolchain to actual eBPF programs later. So to verify that the eBPF programs that we write are sound and safe and work as intended, they get run through the eBPF verifier, which is a static analysis step. That is the first step that is run. And then on top of that, once an eBPF program is validated, of course, we have additional tests on top of that for every specific feature that this enables. So basically, there are two steps. The first step is the eBPF verifier itself. This is something that you do for all eBPF programs. And then we have sanity checks for the intent of eBPF programs. So is it doing what it's supposed to be doing? And to do that, we use typically integration tests and conformance tests. So for example, if there is conformance test coming from Kubernetes upstream that verifies that with this specific network policy in place, this traffic should go and this traffic should not go, well, we have tests that verify that this is happening as intended with the eBPF program that is responsible for doing that. Does that answer the question? I hope.
So another question from Hamza who is asking, when actually you are running a lot of code inside the kernel space and it's like gaining superpowers. So do you have any things or hints to say, okay, now we are going too far? Is there any performance issues, that kind of stuff, running everything in kernel mode? Or maybe crashing.
Yeah, so that is also a very interesting question. I am not personally an eBPF developer. I know how to write hello world in eBPF and hook onto specific syscalls, but that's about it. What I can tell you from talking with eBPF developers is that typically one of the most common issues they have is actually complexity issues. And when they mean complexity issue, it's just that the program they write is so complex that it does not pass the verifier step. Because the verifier is a static analyzer, what it does is it exhaustively runs every part of the code paths, one by one, all of them. So if your program is too complex, there are too many pathways, then the verifier at some point, it just stops and tells you that your program is too complex. So that means that when you are trying to make something a bit complex in eBPF, you have to break it down into several smaller modules that run independently and have to pass data between each other. So this is typically one of the things that are not so easy when writing eBPF. But typically this does not create issues by itself in terms of performance or scalability. It's exactly like microservices. Once you know how to do it right, well, you basically can scale it indefinitely. And there is very little overhead to eBPF itself in terms of kernel space. We also have benchmarks about that, actually, to look into how eBPF is impacting load inside the kernel if you have too many programs loaded on specific events or whatever. But this is like anecdotal compared to the gains that you have with eBPF.
So Cilium can be integrated with OpenStack, with AWS, with Microsoft Azure, all of that.
So the question is, with which cloud providers is Cilium able to integrate with? And I am showing again the slide from earlier. This is the list of all cloud providers that we actively support. It can work on other cloud providers. It may not work if it's not officially supported. It may require some specific integration. So this is the list that we officially support. Typically, of course, since the biggest one is AWS, most of our users are on AWS. But this is not the sole case.
Thank you again.
Thank you, everyone. Now I will hand the microphone back to Smaïn. Thank you, Smaïn, for inviting me again.
Thanks to you for coming, and maybe we will plan another workshop maybe on Cilium. This will be interesting. So we are going to switch to the second talk. Just a moment. So yes, so we're here today with Mathieu in order to give you feedback on a recent tool that we introduced at KMTX. This tool was introduced in order to improve the developer experience, and this will be done. The talk will be in 3 parts, basically. The first part will be just to give you the context and our usual workflow. And the second part, we will talk about Crossplane and how we use it today at KMTX. And we finish with a demo. So I'm Smaïn. I'm basically an SRE, DevOps / sysadmin for years. And I'm working on Kubernetes since 2015. I'm helping, I helped already a few companies in their cloud native journey. And as side activities, I'm the CNCF ambassador, and I'm the organizer of this meetup, one of the organizers. And currently, I'm working at KMTX, and I'm leading the SRE team.
And I'm Mathieu. I'm a backend web developer. I worked in many startups, including Backmarket, for instance. And today I'm part of the KMTX SRE team to help on developer experience topics. Okay, so first, I will try to give a bit of context. So about the company, I will be quick. We're a net tech company. We're actually releasing a new product allowing to launch marketing campaigns on connected TV in the US, which is a new market. And worth to say, it's a technical challenging environment. Today we handle around 100K requests per second, and we plan to do 10 times more in 1 year. And for all this huge traffic, we have to respond in 10 milliseconds top.
too fast.
So actually, now I will give a bit of context about this presentation. Actually, this is a part 2. We did a previous one focused on Flux CD and explaining how we did choose to use GitHub principle and also CI/CD to industrialize our technical stack. So when we joined the company, like programs in place were already fulfilling business needs and handling the load quite well, but it was lacking a lot of automation and industrialization around. Like developers were basically sending code to production from homemade bash scripts run locally, building some Docker images and sending that to production, which was not really okay and not really scalable. So SRE team was created to drive the change. And as we presented in the last presentation, we handled the migration from ECS to EKS, so moving to Kubernetes on AWS. And also we did solve the manual release issue, implementing a CI/CD pipeline using a GitHub Action for the CI and Flux CD for the CD. And we're still pretty happy about that choice. So our target was first to focus on developer experience, like keeping time to market of the feature very fast. Also, we have to support the company growth, which brings some challenges. We absolutely want to avoid SRE team being a bottleneck. Even if we are a small company, we are also a small team. So we can't afford to be a bottleneck. And for that, we have to provide the right level of ownership to our developers. So that's a tricky part. It doesn't seem so, but defining a right level of ownership in a company is pretty complex. It depends on many things, your structure, your way to work, processes, your context, many things. So it may require a lot of iterations, but we did want to focus on finding the right balance between autonomy for our developers and security, and also be the most efficient we can as a tech team. So to try to define the right level of ownership for us, we did start by analyzing our context. So we are a small company, 50 people, including 20 tech. Growing company, so we have to anticipate onboarding topics like onboarding newcomers very fast and potential team split and ownership moving. So I know back market know pretty well this kind of things. Pretty interesting, pretty important for us. We did estimate engineers in place were pretty skilled, and by that we mean they are totally able to master very quickly a new technology if they are well trained and accompanied enough. Also, they are totally used to work with a wide set of different technologies. And very important, we have total support of our hierarchy for the beginning to spend time on training. And if you don't have that, maybe the right level of ownership will not be the same. So based on that context, we define our level of ownership. We don't want our developer just to ship code. We want them to own the full scope around it, from deployment and orchestration to define monitoring, alerting rules, write on duty run books, handle production incidents, keep an eye on costs. So they are not just shipping code. And to allow them to own this scope pretty easily, we have to make them able to define as much resources as they can close to their code. So we decided to allow to define Helm charts within the application repository, including secrets, configuration, auto-scaling rules, network policies, Cilium, monitoring rules, alerting. They write themselves on duty run books when an alert is triggered. What do I have to do? And to allow them to know that, because they didn't know anything about Kubernetes, and that's a pretty new environment for them, we had to like do a lot of workshops, trainings, a lot of communication. Like every 2 weeks, we spend half an hour presenting everything we put in place. And then a lot of peer programming, helping them to move on the new platform, helping them implement new services with us. And yes, now they're pretty autonomous, and it's like nice. So to sum up, from Bash, homemade Bash scripts to build images and ship that to production blindly, now developers can like ship in confidence, because when they want to add a new feature to an existing service, they will do a pull request, which is new also. So the CI will be run to check the code meets our quality standards. Then if it's green, it's reviewed, merged. Another GitHub action pipeline will build the new Docker image and push it to our Docker registry. And then the CD comes with Flux CD. Flux CD will fetch the new Docker image from the registry and deploy it on the new Kubernetes cluster. So it's just, I merge a PR, it's automatically deployed on N clusters where my service is declared. Also, if a new version of the Helm chart is defined within the application repository, Flux CD will connect to GitHub, fetch the new version of the chart, and apply it to the new cluster. So the developers have one single place and they can have the hand of anything, but almost anything, because it's not perfect yet. At that point, developer experience has been enhanced, so part of the path is done, but still beforehand, they have to interact with our Terraform repository to provide infrastructure and AWS resources. And that's not okay for us, because we estimate Terraform is not the right tool for us to be efficient as multi-team, working on a single state with no continuous reconciliation, no drift detection. And we did want to go a step further using GitOps, because it fits totally the way developer works, because it's exactly the same way they build software. They do pull requests, they merge, they do reviews, and they can automatically deploy, not infrastructure yet, but that's why we did implement Crossplane that Mana will present now.
Okay, so based on what Matthew said and what we presented in our last presentation, if you had the opportunity to watch it, our target is to be 100% GitOps. So all our workflow, we wanted to use the GitOps workflow. So here comes Crossplane. As Matthew said, yes, we have a missing piece regarding the infrastructure management, and Crossplane is a way to do that. It is a CNCF project that has been open sourced by Hubble, and basically it has been built on top of Kubernetes. It leverages basic Kubernetes features and amazing Kubernetes features such as the declarative approach, the automatic reconciliations. You can benefit from all the ecosystem around Kubernetes. You can use Helm, customize, kube-conform, and so on. And on top of that, it extends Kubernetes with its own resources, its own primitives in order to manage infrastructure. It can do actually much more. It can manage applications too, but its main use case is for infrastructure management. And we have a feature with Crossplane that brings a higher level of abstraction in order to for the developer to be self-sufficient. Switch too fast. Okay. So when you install Crossplane the first time, you have to choose what we call a provider. So you basically you have to install a component that will interact with the cloud API. You already have with Crossplane major cloud providers such as AWS, GCP, Azure, and so on. And just yesterday, a new provider has been released, DigitalOcean. But you have many more providers here is the list, and we will share the slides with you. But you have plenty of providers. You have, for instance, you can manage Kubernetes applications using, you can manage Helm release, Kafka, GitHub, and so on. And regarding our use case on AWS, we chose to stick to the historical provider, which is named provider AWS. And recently, a new provider for AWS is available. And basically, it has been generated using a project, a Crossplane project that is named TerraJet. And this project allows to generate Crossplane configuration, Crossplane providers from Terraform configuration. That way, you can benefit from all the resources that are available already on Terraform. But yet, it is still young. So let's take a basic example. Let's say that I want to create an SQS queue on AWS. The only thing that I have to do as a developer or an operator, I just have to apply a YAML file, a simple YAML file, using a kubectl apply or your usual workflow. And here, when you create this resource, Kubernetes, actually Crossplane provider, Crossplane operator, will be in charge of reconciling the desired state, basically what you declared on Kubernetes, with the actual resources that is running, that is available on AWS. And here we provide a few parameters, and if I change anything in these parameters, it will be automatically updated on AWS. This is worth noting that we added a parameter to that in order to keep the resource, even if we delete it on Kubernetes. We want it to be safe to begin with because we are still in an exploration phase. And so even if you delete the resource, you will have to clean up the AWS resource manually. And then for more advanced use cases, I talked about a higher level of abstraction. There is a feature that comes with Crossplane that is named composition. And composition is basically a way to give a really simple interface to the developer, an opinionated interface to the developer in order to abstract all the AWS resources, all the cloud provider resources that are generated under the hood. I will explain. So you have two parts. The first part is what we as SRE team or platform team will provide as an interface to the developer. And the developer will just have to set up a new YAML file, and we'll dig into that. They just have to use this interface to create a set of AWS resources. So in the left, you have the composite resource definition, and the composite resource definition is basically the Open API spec. So these are the parameters as we, SRE, are providing to the developers. And then these parameters are consumed by what we call a composition. The composition will be in charge of generating, yes, the underlying AWS resource. And we'll take an example, a concrete example that we provided to the developers. Regarding the composition that we provided, here the example is about what we call IRSA. And at KMTX, our application often interacts with AWS. They consume S3 buckets, SQS queues, DynamoDB tables, and so on. And in order to do that, you have to provide the proper level of permissions. And in EKS, there is a feature named IRSA, which stands for IAM role for service accounts. And this is a way to provide a really fine-grained permission at the pod level, at the application level. And for that, you will have to create 3 AWS resources, a role, a policy, and a policy attachment. Role policy attachment. So how do we do that? We created a composite resource definition, XRD for short. And so we created our own API, and it's maybe a little small, but you can see that this is our own API on the top of the YAML file. And we decided, we as SRE, the API to offer to the developers. And then we created a composition, and so we consume the parameters that are provided by the developers when they call this, they want to create an ERSA, and we create under the hood the three resources: a role, a policy, and a role policy attachment. And on the developer side, they just have to create a YAML file. They can include it. They are included it to their Helm chart into their own application repository. And they just have to set two parameters: the service account and the policy document, the IAM policy that is expected in order to the application to work. Before that, before we came with Crossplane, the developer had to switch to another GitHub repository, create 3 block configuration blocks in Terraform, plug them together, and Terraform apply the change. With that, it's really simple because it is included to each chart, and the permissions are available right away. Another thing we wanted to consider is to, when we implemented Crossplane, is to actually manage the resources that were existing before Crossplane. So there is a simple way to do that with Crossplane. You have to ensure that the name you created in Kubernetes matches exactly the name that is available on AWS. And sometimes you have to enforce that relationship by adding an annotation, external name. But yet, Crossplane is still young, so we are moving with caution. We already talked about the provider. We wanted to stick to the historical one, but we will maybe study the TerraJet alternative in the future. And the second point is about the deletion policy. We talked about that. We don't want for an automatic process to delete an AWS resource that have been created. And yes, obviously, it is not as mature as Terraform. And for instance, we were using tools such as TFSec, Checkov, in order to check the security of the resources. And now we didn't find an alternative yet for Crossplane. And yes, the last point is about the resources that we allow the developers to create, because basically we don't want them to create anything on AWS. So we defined a strict list of resources that we can use with Crossplane. Simple resources such as S3 buckets, SQS queues, SNS, DynamoDB tables, and so on. And the ERSA that I talked about. So now we're going to switch to the demo, but before that, I will just explain what I'm going to try to do. So we will, in the left, you can see that we have our repositories. So at the bottom is the Flux, basically the Flux configuration. And at the top, the application repository. So the developer will just have to handle the application repository. And that we mentioned with Mathieu, everything is under his repository. You have all the resources. You can define the SQS queues, the permissions with the ERSA composition. And basically what we'll do is to merge a PR that enables the deployment of this application, and automatically it will be deployed on a cluster, and it will be able to consume queues, messages from the queue. And it is a really dumb application. It does print the message on std_out. Sorry, we need you.
Sorry, no sexy assistant today. You have to deal with me.
want to stop sharing. Where is it? Okay, it's oh, je peux faire, mais c'est pas ça. Ouais, c'est le stop. Ah non. Comment c'est? C'est là? Je ne sais pas comment je vois. C'est bon. C'est bon, on voit tout. Ok, great. So here we will check that the queue doesn't exist. Ah. Excuse. So it exists. We didn't delete it.
I forgot to delete it. Okay.
So now we're gonna delete it. Now I have to authenticate.
It will just go back to the existing resource. It will be as we import an already existing resource.
But anyway, the application doesn't exist, hopefully.
No. And AWS, you can check AWS IRSA policies. I think it does not exist.
Okay. Here we're gonna see the claim. We're gonna check if the claim. So the claim is the user interface for Crossplane, if it exists, and it does not. So we will merge the PR and it will deploy all these things, and it will get the reconciliation for the SQSQ that already exists. Because as we mentioned, we chose to stick to the deletion policy orphan. So Mathieu forgot to delete it. Okay, let's. Okay. So as you can see, it's just enabled our application to be deployed on the target cluster. So let's merge that. And yes, in a few seconds, we will see the container. Yes. Forgot to do that. Okay. While we are waiting, I will just show you the application repository, such as you get the actual tree and source. No. So here is the application repository. You have basically the pretty dumb code that we have for the demo, and we have the chart in the application repository with all the resources that are deployed with that. And you can see here that we define the SQSQ inside the IAM chart, as well as the IRSA, the IAM role for service account resource. We can see here that is as our own API, and we are using the composition IRSA. And the developer will just have to provide the service account name and the IAM policy, which basically allows to read from the SQSQ. So now we can see that the IAM role for service account is available, and it is synced. So that means that the IAM permissions are available. Let's see the pod. The pod is not started. It is still pending. Right. Just wait a few seconds. I don't know why there are two. Okay. Okay. No, it's okay. It is running. So now let's try to send a message to the SQSQ and read it from the application. No. Off. send. Okay, I will send from here. I have my command line. So the command line is basically sending a message into the queue we created just before. Let's get to the logs. Okay, and send the message. So we can see that we received the message successfully. That means that we successfully used the permission we provided with the composition. And let's just get back to the Crossplane resources that allowed that, because we talked about that quickly. So let's get back to the composition schema. So we basically provided a composite resource definition. This one is in charge of providing the API to the developers. You can see that like that. Oops. So here you can see the parameters that we provide to the developers, and we are default parameters that we as SRE set, such as the abstraction, the complexity is abstracted. The developer don't have to know about these things. And then we consume these parameters using the composition. Composition, what are you doing? So this is the ERSA composition that we talked about, and basically, if you have a look to that, it uses the parameters that are provided using the claim from the developers, and set a few things to create the AWS resource, such as the policy here you can see, or the IAM role for the policy attachment too. And the role policy attachment is here. But we didn't talk about this one because I wanted to show you that here. Basically, from the developer perspective, they will use what we call a claim. And the claim is a namespaced resource. And this is basically the way to provide the interface to the developers. But under the hood, it's always a composite resource that is created. And the composite resource is a cluster scoped resource. And let's have a look to that. So as we mentioned, there is a claim that has been created using the Helm chart. Get ERSA. And yes, so you have the IAM permission here and the service account over there. But under the hood, it generates a composite resource that you can find here. Yes. And this composite resource is the one that is managing the managed resource. What we call managed resource is the actual AWS resources. So here you have the role, the policy, and the role policy attachments. And let's have a look to all the managed resources that are already created in this cluster. It will take a few seconds, but in order to just show you all the AWS resources that we manage into this cluster. So as you can see, we have our SQS queues, the SNS topics, the subscription, the buckets, and all the related stuff to the IAM roles that the ERSA, sorry, that have been created previously. That's it for the demo. Let's switch to the presentation.
Okay, so if you have some things to bring back from this presentation, I think there are many things to say, but the key points here are, in an organization, finding the right level of ownership is tough, but it's key. And all your implementation, all the tools you will have to answer to your needs. So first you have to define your needs. Always over-communicate. It's very important to keep people engaged from day one and all over the path. And also, yes, we want kind of use Kubernetes as a universal API, like allowing not just to interact with basic Kubernetes resources, but also with many things. So our developer, once they master the context, they just can use it to do pretty much anything. And some feedbacks, we didn't have a lot, but we have one which was actually kind of a joke. We won't need you anymore. And for us, that's a victory because we don't have to work anymore, but not really, because we don't want to be a bottleneck. We are free in the team. And if they don't need us anymore just for support, explaining things they don't understand, then it's a victory for us. So that's the end of the part 2. Maybe there will be a part 3, I don't know. But if you have questions on this one.
First question about the infrastructure as code. The question is about the Kubernetes itself. Is it managed by Crossplane or not?
That's a really good question. Actually, we invested time in creating a Terraform module. The Terraform module is basically built on top of the upstream Terraform module for EKS, but we invested time on that. And as we mentioned, we don't want to put all our eggs in the same basket. So to begin with, in this exploration phase, we stick to the resources that we talked about. And maybe in the future, why not? We'll have to work in all the features that we already put in place in our Terraform module.
And also, it doesn't respond to like a problem we have today. Like having the 3 people of the SRE team working on Terraform is not a big deal for us, but having all the team working on the Terraform is much a big deal for us. So as our Terraform provisioning of EKS cluster is working well for us, it's okay.
And the second question, I don't remember. Yes, how do you configure your EKS Flux CD in order to access your GitHub repository?
You have to watch the part 1.
So it's about the Flux CD? Sorry.
Comment Flux CD
exactly how do you configure EKS Flux CD to access
okay.
your GitHub?
Well, just we are using an SSH key, basically. Simple question, simple answer. We have SSH keys and we connect using that connection.
Yes. Quick question about the developer. What it looks like from their computer? Do they run a Kubernetes cluster on their own computer? Each developer runs his own Kubernetes cluster. How does it?
Cool. Yes, it's a good question. Crossplane is basically running on the target cluster. We chose a pattern where a Crossplane, we have an instance of Crossplane per cluster. This is not common. Most of the use cases are using a Crossplane, a centralized Crossplane control plane, but we chose that for simplicity. So no, nothing on the developer laptop. They just have to interact with GitHub.
Okay, so that means they cannot use SNS or SQS or other. I mean, they cannot pin or an S3 bucket just to run some. When they're in there, they're in a group. I want to understand how they interact with Crossplane, how they interact with AWS.
They use the policies they created first with Crossplane. Okay. So that's not perfect, but it's working.
Yes, that's actually an improvement area. We have to work on the local developer experience But yes, today, just to give you a reminder about our first talk, they are using Docker Compose locally, and they are running tests locally using Docker Compose.
They don't know anything about Kubernetes.
They actually work remotely with Kubernetes. They are managing all the application lifecycle from the development using Docker Compose to the staging to the prod, and they are managing the prod issues too. So they are really owner of the whole lifecycle of the application.
And in addition, some do. Some developers run Kubernetes locally, some don't. We don't provide any tool for that yet. We have some very simple microservices.
Okay.
So with just mocking the dependencies is enough to work pretty efficiently. We don't have anything very complex. So far it does the job, but in terms of developer experience, we still have to improve on local development. But we started with something with no pull request, no branches, nothing. So it's already an improvement.
Last question. Two questions actually. Yes, so how do you manage Crossplane and resources when you have multiple users, multiple clusters, and multiple AWS accounts?
Try to answer that one, but yes, we have multiple clusters, we have multiple users, and basically just have a simple answer to that. They are just using GitHub, and everything is done through GitHub. So we have a process. For that, we have to talk about Flux CD, how it works, but Flux will listen on branches, on a given branch, and each cluster is independent in the continuous deployment workflow. So it fetches the changes that comes from GitHub.
Actually, the only thing they have to do is naming resources well on AWS, including the environment. Because with Flux CD, like our Git flow is very simple. When you merge something on staging branch, it's auto-deployed on staging. So then when you merge a pull request on staging, it will auto-create all the Crossplane resources where the application is deployed. And if your application is deployed on 1 or 2 or 3 production cluster, when you merge a pull request on the main branch, then it will be deployed on each single production cluster. And then the Crossplane resources will exist in all single clusters, and it will create resources on AWS.
I just want to add something about that, because yes, we have different patterns than the common one using a central control plane. So this is something that you should be careful. You should not manage the same resources from different operators. This is something that is really annoying when you have to update a resource on a given cluster, and it's continuously trying to reconcile.
And a final question, I think. I'm going to read it. I guess Crossplane is actively controlling that AWS resources are in sync with Kubernetes definitions, but isn't it hammering the AWS API, risking to reach the API quotas or cost limits?
Yes, this is a good question. I don't have a precise answer about that, but I read about performance issue basically with the TerraJet provider, which comes with many resources, and yes, it brings some challenges in terms of performances in the API. But with recent Kubernetes versions, it has been fixed. Okay. Yes, that's one.
How do you ensure that how do you enforce security? policies for all the clusters. You don't want some person to get some high privilege, or you want to make sure that this person cannot deploy a 32 CPU VM. How do you do it?
Okay. Yes, I forgot. I have to repeat the question. How do we handle the permissions on Kubernetes? We don't want a developer to, for instance, to create any resources or to provide too much resources to its application. How do we handle that on the SRE team? I guess. Yes. So just for the usual use case, you need to enforce using RBAC. So the RBAC Kubernetes RBAC. So that way you ensure that a given group or a given team in a given namespace will just be allowed to run the resources that we allowed. So this is the first thing that you can do. And the second one is to use what we call a gatekeeper, such as Kyverno or OPA. But to be honest, we didn't do that for the moment. And as we said, we are a small company, pretty small company, and the development team developers are really skilled. But yes, what we are trying to do is to give them the ownership. So they are responsible of issues if they happen, and they are responsible to give the postmortem, to present the postmortem. So really, we insist in that. Welcome.
Are you using multiple AWS accounts?
The question is if we are using multiple AWS accounts. So, because we are currently creating a new organization with multiple accounts. Previously, in the past, we had just one account. And to be honest, I don't know if there are issues with that. I don't know yet. We are building that.
And right now, you are using only one dedicated cluster for this, or you are using the same Kubernetes cluster for all the.
Yes. So the question is, are we running just one cluster for running Crossplane? Or yes, okay. Or are we using multiple clusters? So to answer to that, we decided, as I said, to stick to a pattern for with a Crossplane operator per cluster. We have multiple clusters, but we have also a Crossplane operator per cluster. And what we have to ensure is that a given resource is really managed, reconciled only on a single cluster. This is something that we are in charge to ensure it doesn't happen anytime. Okay. Okay, so thank you all. Thank you for coming. And thank you for the ones that are still there in the Zoom. So we'll try to share the video. We are trying to publish it, and we will share the slides. Thank you.